One other skill you need to know how to do is to find the derivative of an inverse function at a specific point. Now, before we talk about derivatives and how this applies to calculus, I want to just make sure you still remember what an inverse function is. So if we have the function y equals x cubed plus 1, and they tell us to find the inverse, then the process is to swap the x and the y, and then solve for y. So I'll subtract 1 from both sides, and then take the cube root of both sides. So x cubed plus 1 and the cube root of x minus 1 are inverses. If you look, they do exactly the opposite things in the opposite order. The original in black there, x cubed plus 1, cubes a number and then adds 1. The blue one, the inverse, subtracts 1 first and then cube roots it. So they do opposite things. Now, that's all well and good when it's a simple equation like that. You can find the inverse without much trouble. But what happens when you have something like this? Then how in the world are you going to be able to swap the x's and the y and then solve for y? It's practically impossible. It's super difficult. So that's why they wanted a quicker way to find the derivative and talk about the slope of these inverses when they weren't able to easily find the inverse function. So the rule is right here. It says if f and g are inverse functions, then g prime equals 1 over f prime of g of x. Now that's a formula you do need to know how to use. One or two of these problems could show up on the AP test, particularly on multiple choice. It has before. Now I want to show you how they arrived or how they derived this formula, but you don't have to know how that happened. I just wanted to help you see where it came from. One of the properties of inverse functions is that if you put one inside of the other, f of g of x or g of f of x, it works the same either way, then your result is going to be x. So a really simple example of two inverse functions would be x squared and the square root of x. Well, if I plug the square root of x in here, I'm just going to get x, or if I plug x squared in here, I'm just going to get x. That's just one of the properties of inverse functions. You'll see the same thing if you plug this one in here and so on. And we just recently learned how to take the derivative of composite functions. You do it with the chain rule. So if you take the derivative of the outside times the derivative of the inside, then the derivative of x is 1. Whoops, sorry, that's not the derivative of the inside. This is the derivative of the inside. The inside is g, so the derivative of the inside is g prime. Now, all you have to do to get their equation is divide both sides by f prime of g of x. And that leaves you with just their equation. G prime equals 1 over f prime of g of x. Like I said, you don't have to be able to reproduce what I just did. The key that you remember and know how to use is this equation that I'm boxing right here. Okay, let's do an example. If f of x equals 1/4 x cubed plus x minus 1, and what this means right here is that g is the inverse, that little negative 1 there means inverse, g is the inverse of f. What is g prime of 3? So notice, we not only don't have the derivative of g, we don't even have g. But using this equation, we can do this. We can do g prime of x equals 1 over f prime of g of x. That's our just general equation, and we are specifically looking for g prime of 3. So look, think about this carefully with me. We're trying to solve for g prime of 3, and as we look, we right now need to figure out what g of 3 would be. Well, normally if we had g, we would just plug in 3, but we don't have g, so we have to be a little creative. If you remember, to make an inverse, you just swap your x's and your y's. So let's think about it this way. We're trying to figure out if we plug in for g, if we plug 3 in, what do we get out of it? In other words, we're trying to figure out that y value right there. Well, f and g are inverses, so they're simply the x's and the y's flipped. So where g has an x value of 3, f will have a y value of 3. So if we take f of x and set it equal to 3, then we should be able to find out what x value goes here, which would correspond to the y value that goes here. The simplest way to do this is with your calculator. Go to y equals, plug in 1/4 x cubed plus x minus 1. I hate when I do that. There, that's better. 1/4 x cubed plus x minus 1. And we want to know where it equals 3. So I'm going to put 3 in y2. Because I can find out where these things equal by finding out where the two graphs intersect. I may have to zoom back out. We'll see. Oh, no, it's showing it. Good. So I'm zoomed in a little, but you can see where they meet. So I'm going to go to second calc. And I'm going to go down to number 5, which says intersect. This will help me find out where these two meet. So when it asks for first curve, you just move the cursor as close as you can to where the two of them meet. Okay, and then you hit enter. Second curve, do the same thing. Make sure it's close to where they meet. Hit enter, and I guess just hit enter. So they meet at 2, 3. So we know that F has the ordered pair 2, 3. Well, since G is its inverse, it must have the ordered pair 3, 2. So now I go back here and I know G of 3 has to equal 2. So I plug that in. Now I have F prime of 2. So now I need to find out the derivative of F and plug in 2. I'll tell you what, we'll color code a little bit. So if I take F prime, that would be 3/4 x squared plus 1. And then I plug in 2. So F prime of 2 will be 3/4 times 4 plus 1, which is equal to 4. So if I plug in 4, I get my answer, which is 1/4. So G prime of 3 is 1/4. Okay, I realize this may not seem super natural to you, but I promise as you do more of them, you'll see the pattern and the steps really do follow each other really well, and once you get it, you'll get it. So now we have the equation x cubed plus x, and we're told that G is the inverse of F, and they want to find out G prime of 2. So let's go back to our original equation. G prime of x equals 1 over F prime of G of x, and plug in 2. So G prime of 2 equals 1 over F prime of G of 2. So we need to figure out G of 2. We're going to do it the same way we did on the previous problem. We know for G, where it has an x value of 2, F, its inverse, must have a y value of 2. So I'm going to take my F and set it equal to 2. X cubed plus x and 2. So let's go to our calculator, plug in x cubed plus x, and plug in 2 here. We want to know where they meet, so we go to the graph, and we go to second calc. Remember, I'm a little zoomed in, so if yours looks a little different than mine, that's why. We get as close as we can to that intersection. Just keep hitting enter, and we find out the intersection is at 1, 2. So if F has the point 1, 2, then G must have the point 2, 1, because they are inverses of each other. Their x's and y's are swapped. So now I know that G of 2 is equal to 1. So 1 over F prime of 1. Okay, so to find F prime of 1, I take the derivative of F. I get 3x squared plus 1, and I plug in 1 for x. So F prime of 1 equals 3 plus 1, which is 4. I know it's a coincidence, but we ended up, again, with 1/4 is our answer. So hopefully you started to see there really is a very set pattern here to how we approach this. One other way they may give you the information is like this. Given f of 3 equals 15, f of 6 equals 3, f prime of 3 equals -8, f prime of 6 equals -2, and that G is the inverse of F, find G prime of 3. Now this may look worse and more complicated, but it actually turns out a little easier than the two we did before. But you have to know what you're looking at. This is an ordered pair, 3, 15. This is an ordered pair, 6, 3. This is really a slope, but it's telling you the derivative at 3. Same here, this is telling you the derivative at 6. But all that information is based on F. What we're trying to figure out is something about g, the inverse. Now this, keep in mind, they have to tell you that f and g are inverses. You don't need to assume from here on out that they always are, unless we're dealing with this type of problem. But f and g for this problem are inverses. So I use the formula we were given on that first slide, g prime of x equals 1 over f prime of g of x. And I'm told to plug in 3. So g prime of 3 equals 1 over f prime of g of 3. So my first step is to figure out what g of 3 would equal. So again, for g to have an x value of 3, that means f must have a y value of 3. Well, we don't have an equation this time to set equal to 3, so what do? Well, if you look back up at the information they gave us, we already know where f has a y value of 3. It's right here. F has the point 6, 3. And if f has the point 6, 3, then its inverse g has the point 3, 6. So we know that g of 3 is equal to 6, so we can plug that in. 1 over f prime of 6. Okay, so now we need to know f prime of 6. Well, previously we would have just taken the derivative and plugged in 6, but we don't have an equation. Again, if you look back at what information was given to you, we know what f prime of 6 is. It's negative 2. So we just plug in negative 2 there, and we have our answer, which is negative 1/2.